Crash Course Instrumentation, Episode 18, Series vs. Parallel, Why It Really Matters. It's one of the first things you learn in electricity, series versus parallel circuits. But do you really understand how it affects safety, troubleshooting, and performance? In this episode, we go beyond textbook definitions and into real-world implications. These aren't just theory. They're decisions you make every time you design, install, or troubleshoot a system. What you'll learn. How current and voltage behave differently in series and parallel circuits. Why resistance, failure modes, and fault detection depend on wiring choices. When to use series versus parallel in instrumentation and control systems. Real examples: sensors, alarms, and loop wiring. Historical context: how series versus parallel design shaped early electrical grids and industrial safety systems. Series circuit breakdown. One path, shared current. Voltage divides across each component. One failure takes down the entire loop. Common uses: e-stops wired in series for fail-safe control, alarm indicators, overload relays, and safety chains. Downside: one broken connection and the whole system fails. Historical flashback. Thomas Edison's early electrical systems were primarily series-based, until parallel distribution proved to be more scalable and fault-tolerant. The shift was critical to the rise of safe, reliable lighting systems in cities. Parallel circuit breakdown. Multiple paths, shared voltage. Current divides based on resistance. One failure doesn't necessarily stop the rest. Common uses. Analog sensor loops. 4 to 20 mA transmitters often parallel across supply. Lighting systems, signal conditioning networks. Caution: one shorted path can sink current or pull down the voltage for everything else. Design tip: use current-limiting resistors, fuses, or buffer amplifiers to protect each path in parallel designs. Proper isolation prevents crosstalk and ground loops. Real-world trouble: a tech wires multiple transmitters in parallel without isolators. One shorts. Now the controller reads garbage data from all the sensors. Bad design, costly downtime. Pro tip: always validate your parallel networks under simulated fault conditions before commissioning. Final thought: knowing the difference is just the start. Knowing when it matters is how you become a real pro. If this helped you level up your electrical game, be sure to hit that like button, subscribe, and ring the bell so you don't miss the next episode of Crash Course Instrumentation. Stay sharp, stay safe, and don't just wire it, understand it.